All right, back. Let's take a look at current events. Where am I at? Oh no, oh no, oh no. I had to reset the UI. All right, let's see the current events. I think I'm gonna take this track off the playlist. Something about the track seems like the sound of it seems outdated to me, really quite outdated. All right, let's see if this is good. Is it gonna say something? I'm watching. It's gonna say, looks like there's emoji bake in there. Oh, but I actually managed to fix it, I think. Oh no, I didn't. The emoji bake. I try to fix the emoji bakes in the output, but this one slipped through. That's too bad. We could take a quick look. It's like, well, I've looked at it on stream before. What did I just click? So if you go in here and say from fix that for you, import, and I think it's fix and explain. And then we try passing in the emoji bake we just got, it might be able to say what the problem is with it. Let's see. So it wasn't able to fix that one. It's pretty good though. It can fix a lot of things. So that's what I used to sort of like figure out what the problem was, and it was using some Windows encoding, and I downloaded like a data table that was full of like fixed encodings basically, and I was really happy with the results, but this one slipped through. So it unfortunately cannot fix all the emoji bakes. So let's get over to Advent of Cyber. I was tired yesterday. I feel ridiculous that I missed yesterday, but yeah, I took it completely off. I mean, I went to work and everything, but I did not log on to any of this yesterday. I just went to bed early. So, now we have 2 to do. So we've got day 6. If I can't find a nice malware to use, I'm not going. Okay, so these are references to quotes from the Jim Carrey movie, right? I gotta say, Jim Carrey, best actor in Hollywood history. Hollywood never had a better actor than Jim Carrey. What was it that he actually said in the movie? Well, if I can't find a nice something, I'm not going. Right? The guy was a goof. It was a good movie, a classic, a classic. All right, so analyze malware behavior using sandbox tools. Interesting, interesting. So we're going to start the VM. So first of all, I guess we can assume that we're going to need to connect to the VPN probably, as we usually do. So let's hop on that VPN. There we go. And let's see. Off the top of my head, I cannot think what these Yara rules are. I'm guessing it's a mnemonic, right? I think Y, A, R, and A each stand for a different rule. But I don't think I've ever encountered it before. Let's see what Yara means. Well, it looks like I was wrong. I thought it was a mnemonic, but no. Huh. Why is it called Yara? Okay, here's the explanation. Yara is a tool used to identify and classify malware based on patterns in its code. All right. Uh-oh, split screen again. So, oh no, my scroll stopped working. My whole page froze. So it says we should be able to use a RDP, right? So we'll do that, I guess. All right. So I'm gonna put this in, I believe, right? Administrator. Try hack me. All right, so we'll log on here, I guess. Oh, interesting. Did this one get cut off? That get kicked off? No, hold on. I want to kick this one off. There we go. All right, and then I don't know why these button icons never loaded. Alright, cool. So now we'll see what we have to do. Oh, really? You don't have to understand every detail of the code. I just skipped over it just now. But I mean, okay, seems like what we just said, right? So there's a registry path with a value. That's what we saw here, right? Okay. Then we're gonna run a command on the regexe. Interesting. So do you think this comes from like Windows system? I don't know what it is. All right, let's take a look. That's pretty small. Can we maybe zoom that up? Maybe. Interesting. All right, let's just do it. Okay, so tools. So there's a Jingle Bells PS1. Oh my goodness gracious. So what happened here? Yara. Okay, so let's have a look. All right. Ginseng. Okay. Where is a new window? Shoot. Said malware, right? Uh-oh. PowerShell new. Hey, look, the text is even bigger. Ha! Okay, so we'll go floss. Nope. Nope, not this one. Oh, really? Extracting static strings. How about that? Interesting. Dash S option. Oh. All right. What did we get out there? Let's take a look. Oh my goodness gracious. Okay. Looks like a bunch, huh? So what do we think we're looking for here? Probably one of the longer lines, I would guess. We probably want to filter out some of these shorter ones, I would think. Maybe, maybe. It does look like kind of a lot. Okay, let's see. So here is something. Oh, wait a minute, wait a minute. Static strings, okay. So I think the one we needed was some kind of a command, right? This. Ooh, THM hidden clue. Let's see what it says. it said hidden clue. All right, let's see what this is. Another premium room, I guess, right? Okay, so we'll close that. We'll go on to the next. That was 27 minutes, basically. That's not too bad. I don't know if I learned much of anything. I think I was sort of exposed to some things that I'm glad that I have now sort of heard of, I guess. All right, so we'll move on. So 11 is finished, I guess. Okay, so 12. So we did open that other room, right? So no answer needed. So it's called Flare VM, Arsenal of Tools, Premium Room, and $10.50 per month. I mean, it seems like if this is something you're really interested in, I think that this price could be well worth it. All right, so let's just hit complete. There we go. All right, so we'll collapse this back down. And AWS log analysis. Let's give it a... I'm speaking in rhyme! Okay, I dig it. Oh, uh-oh, we have to know JQ for exorcism. But this is clearly, you know, a much simpler use of JQ than what exorcism demands. So we are going to start a VM with split screen. Apparently no RDP this time, I guess. So I don't know, we'll see. I should still have the VPN open. So I don't know what we're supposed to be looking at in the split screen. I kind of dislike the split screen, to be honest. So that's starting. I'm not sure exactly what we're expecting to see, but we'll find out soon. So yeah, here's a S3 log entry. Okay, cool. So it was a list objects event. Sure. So we're going to go to logs. Interesting. So I wonder how come RDP is not listed as an option. I guess it probably doesn't matter much. All right, so we're going to take a good look. So it looks like the logs are kind of big, right? So what are we going to look for? JQ. So the -r is for a raw input if it's small, or a raw output. Okay. So we'll go JQ R records select event source and nothing came out. I guess I messed it up. Yep, I misspelled this right here. I probably messed something else up too. Let's see. Event source. Oh, you know, I don't know how I thought that that was S3 and didn't see my mistake. Okay. Well, it's still too much. What are we actually looking for here? So this person said we're investigating for something. Event name here is list objects. Okay, so username glitch. What the? This is a ton. So their AWS API call. Five of them by the looks of it. Okay, what else do we need to look for? Glitch. Oh, it's glitch in 4. So one of them has an event type, but not a username. So what could this be? So we filtered it down to just this bucket. That's all we did, right? Okay. So if we do it again, we can add something to the JQ string, I believe, right? We can say type, and then what if we just want username? So there's no username comes out. Now, to be very honest, okay, I want to show what I would typically do just because I'm more comfortable with it. Let me try to move this. I hate the way they split the screen. Let me try to move this so that it's hopefully more visible here, all right? Let me, why don't I put it right there? Okay, so I would probably do this. If you go into Node, then, oh, okay, let's try. I don't think I have sudo permissions, do I? As far as I know, I do not. Okay, well, I would use Node typically, but if we can't, we can't, I guess. No Docker either. Okay. So this must be a built-in, right? TSV format. And then is column a PowerShell command? I just have -t here, but here they have more than that. Okay. This is good stuff, man. If only I weren't so dumb. So we are going to get the username as I hoped. I didn't bother to see that it was under user identity. Oh. So what's the QR code go to? Can we find it? I think they're going to help us, but I think what we are going to want to do is we're going to want to use AWS to attempt to get this bank account QR ping. Probably. Interesting. So we're getting rid of the key in the bucket name because we're not specifically looking at S3 anymore. Okay, so now we're not just looking at S3. We're looking at everything where the username is glitch, I guess. Is that more readable yet? Not quite. All that. Oh no. Wow. So do we know what we're gonna be looking for? Other than the QR code, presumably. Okay, I'm gonna shrink it again. I did not update the headers before, the column headings. Okay, so let's take a look. Okay, McSkitty. So many in this table. Okay. Gonna try to expand it again. Okay, so we see McSkitty all over the place. Um, so how do we show the non-matching lines? I don't remember actually. It is dash big L. Oh, it's all McSkitty. Oh my goodness. All right, so what do we expect to learn from this? So no column this time. We're just going to look at the whole record, I guess. E. So here is the whole record. So McSkitty. Oh my goodness, we can see the access key ID. Okay, good, good, good. Create the user glitch. Well, administrator access. So that's exactly what they didn't want, right? They were like, oh, it would be devastating if he had administrator access. All right, I dig it. Yeah, so what else should we learn here? Honestly, I would rather work with these JSONs in Node, or even, honestly, yeah, probably Node. Honestly, though, probably in Firefox, check this out. We could probably go into Firefox and just open the file, right? So if we're in this browser and we just go Control O, and then we look for that log that we've been looking at. Whoops. Select. So we've been looking at this one, the smaller one, up till now. So if we were to just open this in Firefox, then we could just go into the console and just mess with it, probably, right? So like the entire JSON raw is in this document body, right? So it looks like it did use some kind of viewer by default to sort of pretty print the JSON, which is nice. So I think these are pretty good options, but I was just gonna probably use the console. Let's see, it's still like that. Let me just inspect. Right, so we can probably go JSON parse records equals, or record, I guess. Okay, so then if we were to go like this, so now like in this console, I just find this just easier just because it's what I'm more familiar with, right? So the record, so now whatever it is that they're looking for, what was it? So they want records where source IP address is that number, right? So there's 63 records in there. Yeah, this is so much nicer right off the bat. So then I would run a filter, basically where we say source IP address, and then we put in the number that we want, right? 5394201609. Okay, so then that's 51 out of it. Isn't this nicer? I think this is actually much nicer. It's way more interactive. It's a super good REPL, right? This is probably what I should have done from the start. Okay, so we filter it down. That was the only filter? Okay, so now check it out. So they say 3 user accounts, but like there's 51 records here. Do I want to look at all 51 of these records? I mean, you know, if it were the job, then yeah, of course you would look at them all. But like if I just want to confirm that it's 3 user accounts, I'm just going to do what we just did and then map. All right, and say set right? Okay, so a bunch of them are undefined, right? And then look how easy we can just very interactively filter and say, and user identity username equals Mayor malware. So this is like, if I'm exploring, then I'm going to want to use something pretty interactive like this. Node is also good. Using like something like a Jupyter notebook would probably make a lot of sense, although I'm not really familiar with that. But I love just using this REPL, like the interactivity of it. is super, super good, right? I can use the mouse to be like selecting things and everything, and like everything is here, right? For JQ is what I would use if it's like, okay, I need an automated pipeline that's just going to do the same thing every time, right? I've explored enough. Now we need to have a pipeline. So then that's where a tool like JQ, I think, would come in. I'm already going to have to take a brief break here. Oh man, that's good. All right. So anyway, so now we are just going to look at the IPs. So we're going to do like this, but man, I wonder if I could have used the remote desktop. I guess probably not, because it didn't give any password for it. Okay, so can we see that okay? It's all the way down at the bottom, but whatever. All right. So now we're not going to filter this. We're going to filter on this user identity username, and then map okay, and say new set. Okay, so Mayor Malware only has that one, right? So then if we just say user IP equals, and then just put U for username, right? And then do new set here, and then just put that username right here. Then we do user IP. Then we do the users that we're interested in, right? Are going to be glitch, McSkitty, Mayor Malware, right? So now we see that Glitch and McSkitty, Glitch had used AWS internal, it looks like, and McSkitty had used 31. Invaluable cinematographer, cheap viewers on True Followers Rue. So how come we have Zalgo text this time? Is Twitch like doing some filtering or something? Does that seem necessary? Or is it just to make it more fun? Because it does make it more fun, I think. And I think that's probably the best reason. All right, so so we're focusing on these questions. So which OS and browser, IP addresses. Okay, so McSkitty. So let's see. So instead of just user IP, let's get the other information that they just asked for, right? The operating systems, right? So the operating system was part of the client user agent, right? The user agent. So let's see what user agents. Can we still see that? Let me move it. Okay, let's see what user agents. So user agent. So this time let's get the user agent. Okay, all right, so what have we got? So Glitch had 5 different user agents. McSkitty only had the one. Macintosh, Chrome. Okay. Mayor Malware had two, which were these, right? S3 console, okay. And this one, Chrome, Macintosh, right? Okay, great. And then Glitch apparently had 5. So let's see these entries. So there was an AWS internal, okay. Then there was a Macintosh Chrome, sure. S3 console, is this the same as Mayor Malware had, it looks like, probably? And then here's Mac Chrome and S3 console again. All right, so sure. Now, what else did they say? Which OS and browser? McSkitty used a different IP address before. Okay, so let's have a look. So out of these 36, if we map to the source IP address, and I'm off the screen again. Okay. So what did they say they had proven? I'm not sure about this. Here, so we can see it was 5394,201. Okay, so then we changed. All right, so what the heck happened? User agent and source IP of McSkitty are different? It looks like I only got one user agent from McSkitty. So did I screw that one up? Oh, I did mess that one up. It was Macintosh, Chrome, and then it became, wait a minute. Anyway, so it was Macintosh, but then it was Windows after that. Okay, okay. So if we do this, and then look at the user agent here, right? And I have to keep moving it. All right. So then are those all the same? It's always Windows. Okay. So then if we use the other IP address, so delete this one, right? And then grab this one. Just I'll just type it in, I guess. Oh, where'd it go? Here. So then here it always used Macintosh. Okay, fair enough. So then okay, so then we have the RDS log. All right, so let's try opening that one. So the RDS log is quite a bit bigger. So they're just gonna grep the RDS log? Okay, fair enough. All right. Okay, so yeah, so this is what it looks like. So if we inspect, it's just plain text. So that's good. So now let's go. So it should be like quite a lot of text content, I think. Or is it yeah, we can just go like whoops. Oh no, oh no. Oh no. I don't know what I did. Um everything went wild. Oh, did I hit? I think some button that I hit must have prompted it to do like a mobile mode or something. I think it's slow because I loaded such a big file, maybe. So probably we're better off just using the grep, and the grep will be good. So let's close the Firefox, I guess, because it has become unresponsive. You know, whatever, it happens. Okay, sure. So they went for all of the inserts. Okay. What is the other activity made by the user glitch aside from the list object action? Okay, so unfortunately, I think Firefox is dead, so that's sad. We saw whatever that was pretty early on. It's a shame I didn't put it in to the answer box when I saw it. Because let's see, it was aside from list object, they did a like a file upload. What is the source IP? Darn, I'm sad that I busted the poor Mozilla Firefox. Okay. All right, that is fine. So let's go JQ. Uh-oh, is it gonna be responsive? I think I locked it up a bit. It doesn't have that much like system resources, obviously. So, oh no, I had just seen like all of this and then locked up the Firefox trying to load the big file. Ugh. Okay, so we know that this one was glitch. And this was administrator. Okay. Let's close this and start it again. All right, I'm gonna start it again. Log Universe, you think this one's premium as well? Seems like all of them that they link to are. I wonder which rooms are not premium rooms. Actually, on my Mac, I have logged into this site and found some rooms that were not premium rooms, just poking around. I just haven't really been poking around on stream all that much, really. Alright, shall we try for Firefox again this time? Yes, I would say so. I think it's just easier. I won't do it for the big file, but let's do it for the small file. A lot of these are in the small file. Okay, so Wareville logs, CloudTrail. Okay, so it formats it, which is great. So we'll look at the raw, pretty print, and we'll go inspect, of course. Okay, so that's good. So now here, we'll say $1 text, not $1, $0. Okay. It's not stringify, it's parse. I did not mess that up the first time. Okay. Okay, so okay, so let's go records, filter. So it was user, let's see, rather than do this, let's do records map. Flat map. So these are all the keys we have to play with potentially. So the one that we want for the username is user identity, right? Let me move it over so we can see again. Oh, that's not too bad, but just bring it right over here. Yep. Okay. Username glitch. Yep. Okay, so we have 15 records here. So we want to know what? Event type. Okay, they're all that. What about the event name? So there's technically a bunch of them here. What is the source IP related to the S3 bucket activities? Okay. Okay, sure. Other activity aside from the list object action. Okay, so if we look here, these are all the ones. So which one are we talking about here? The console login? Um, well, that was one that was called out in the text, right? Event source, what AWS service generates the console login event? Okay, so we'll go, it's IAM, right? We'll see if I'm right. I think it's IAM, so we'll filter the records by event name equals console login, right? So we have 13 console logins. Okay, and then if we look at the event source, which they mentioned, right? Sign in. Oh, okay, so that's not IAM. Oh, okay, well then. Okay. Sign in. Amazon AWS.com. Sure. Okay. When did the anomalous user trigger the console login event? Did I just hit Shift Enter? What? Oh, this is probably different from how it is on the Chrome. No, wait, what is happening? Ah! I don't know what I did here. Control C. Oh. Oh, it's a convenience. Okay, interesting. The Chrome console would just would just give you a red error message telling you what's wrong. But yeah, no, it does seem like a convenience to be able to just hit enter. But in the Chrome console, you just hit Shift Enter when you want another line. It's very simple. User identity. Okay, so we have a particular event time, right? So it was when. All right, 2024. Okay, what is the other activity? Okay, what type of access? All right. So here we're going to look for some kind of policies, right? So we want a let's see these entries. All right, is it so for event names, we have a set of 19, right? See that? Okay. So put object, head bucket, list objects, pre-flight request, console login, assume role, list policies, get policy, create login profile, attach user policy. So attach user policy is the one, right? Okay. And so then we're going to see this is username glitch. And then we want to put administrator access, right? So it's okay. All right, so we're going to look at Mayor malware. Okay, so we'll put this number in. Okay. And then we're going to look for Mayor malware's bank account number, right? So where would we find the bank account number for Mayor malware? It's in the other file, right? The RDS log, presumably. That would be the only one that's in the RDS log, I think. Okay, so McSkitty IP address. We see that. Okay, so we'll do this. All right, so I still don't have this one. What is the other activity made by the user glitch aside from the list object action? So it seemed like there were several things, right? So let's put console login, which was in the text, because I just want to move on, I guess. So that was not correct. Darn. The other activity beside the list objects. Right, so like there's a bunch of them here. All right, fair enough. Okay, so that's that. So now we're going to close the Firefox and find the bank account number. So we're going to go into Wareville. Bank account number owned by Mayor. So let's look at head RDS log. So we have queries. So I think each of these is on one line, right? No, I don't see Mayor malware, apparently. Um, I'm a little disappointed. That was like more immediate to find it than I kind of hoped. That one took me forever, actually, like legit. And it's probably, honestly, like I'm all, we can do it all in Firefox, but messing around in Firefox or whatever is probably what made it take way longer than it ever needed to. Let's terminate this. Okay. So, I am going to be right back in 5 minutes and come back for Advent of Code. Let's do it. All right, be right back. All right. I do not have high hopes. Oh my goodness, my energy is so low. We'll see. We'll see if tomorrow's any better. But for now, oh wait, where's my music? I haven't had music this whole time. Like, I think it turned off like an hour ago or more. All right. All right. Oh my gosh. Okay. Why do we not have any margin here? So crazy. Okay. All right. So example map. So a guard. Okay. Obstructions. Sure. If there is something directly in front of you, turn right. Okay. Otherwise, take a step forward. All right. So let's imagine. So he goes forward. Oh, there's something directly in front of me. So I go right. Okay, sure. Here I am. Okay, now I have to turn. So down I go. Uh-oh, uh-oh. I have to turn again. Here I go. Okay, sure. All right, okay, and now I have to turn. Darn it, why do I keep having to turn? This is messed up. Okay, here we go. Oh no. Here I am again. Down. Ah! I have to turn twice in a row. Okay, here I go. Uh-oh, did I end up in a loop now? Oh, left the area. Oh, okay, okay. So get the number of positions. All right. Okay. So this first part should be straightforward enough. We'll see what the truth ends up being. Let's take a look. Okay, so I equals this. I split. So we could maybe do that. Looks sensible enough, I suppose. Okay, so then we'll go, so I guess do we just want obstacle-like locations, basically? Okay, so we'll say if so let's say directions. Directions equals is that gonna help me? Not really, right? I might as well just leave it as what it is. No, that's not it. There we go. Okay, so we can get that direction, sure. Um, we should probably stop working after that, I guess. So I got 4, 6, 0, 1, 2, 3, 4. No, that's not it. Oh no, wait. I have it by XY, so 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6. Okay, yeah, XY. XY, sure. Um, so if we have the pause and the direction, then that sort of gets us started. So let's sort of like put all that into a function. So get pause equals I. And what did we need to do? We needed to say direction. So let's say it's get start, and we'll return the direction as well. And so then we'll say const, and then we'll do the direction here, right? And then we'll say this. So I is still that. So I have up, and then the pause says 4, 6, okay. All right, so that kind of gets us the starting position. Now we need to actually do some work, I guess. So for the start, let's say dir equals, so that's going to be so in this case up, so we want to go 0x minus 1y, right? Okay, so for the direction, I have 0 minus 1, and for the pause, I have 4, 6. Okay. All right, all right. So then the hash is the only obstacle? Yeah, it says that. Okay. So then we'll say can walk equals, and it'll take a guard and an I guess. And then we'll say next equals okay, so let's just take this as the pause. I feel like this is almost like, is this unnecessarily just a little goofy? I'll leave it for now. Something about it, like, I'm thinking, Okay, so let's say can walk get start I, and it says undefined for oh, I didn't, yeah, I didn't pass it in. Okay, so it says true. I guess so far so good. So then I guess I don't think we really need to check can walk per se. I actually probably yes. So I'm gonna say dirs equals, and I'm just gonna make an array of them so we can cycle through them easily. So when we turn right, it'll be 1, 0. When we turn right again, it'll be 0, 1. When we turn right again, it will be -1, 0, right? So we can cycle through those. So then I guess we have to have like a position in bounds, right? So can walk if we try to do this and it's out of bounds, then I think it's gonna make an exception, right? So I guess will exit would be let's do get next. So then will exit equals dir pause I const next equals get next dir pause, and then we return next sub 0 less than 0 or next sub 0 greater than or equal to I length. Well, what did I pass in as I? Oh wait, there's no way. No, I needs to be an array. That's crazy. Yeah, I is still just a string. Okay, so guard map equals I split map L split like this, right? So when we did get start, I actually did split it like that, right? So let's not do that. Let's go back to the get start definition and let's put the guard map maybe just into there. So then this becomes guard map find. We don't have to split, this just becomes A. And then when we return, let's return the guard map as well. So I is still the string that we came in with. Okay, good. All right, so then when we go get next is fine. Okay, so I'm going to start putting these into my file somewhere. Probably. Or just kind of start combining them. Okay, so this'll be solve equals I. Okay, so then the first thing we'll do is say game state equals get start I. Okay. And then get next will be here. I said get next, but what the heck did I actually copy? Okay. Okay, so then this is not it. That's nonsense. Don't know why I got it. Okay, so we'll define the get next. Okay, so then the can walk is now going to be different, right? Is that the most recent can walk definition? So it's going to be basically like this. Okay, so we'll say const. Okay, so now this will be guard map, and we won't do that. Okay. Okay. So we'll say while can walk. Oh, but I didn't do out of bounds. Okay, so I started to do will exit. So let's do will exit here. So const will exit equals dir pause guard map. And then we'll say, okay, so this should be get next. Okay, let me put that in there so I make sure it's saved. Okay, let's keep working. Okay, so will exit. Okay, so then, did I have anything? Yeah. Okay, so we'll say const next equals get next. And then return really, let's call these just X and Y, I think. Let's do that here as well. Okay, so that's pretty much it for that one. Okay, save that. Okay. So keep working here. All right, so then we're going to say while not will exit game state. So we'll let count equals 0. So then we'll say count plus plus here. And then after here, we will return count. Okay. And so then this will just be game state equals next state game state, right? And then so next state will say, let's say const turn equals, and we'll pass in dir pause guard map. So I don't have the directions listed in here. So I listed out my directions as this, right? I have that part. Where did I do this? Oh. So I think the dir itself should just be the index. I guess that's okay. You could do like an index of, but I think for this, that is probably fine. I don't know if an index of would be better. I think this is fine. So the dir itself will be a number then. So that means So that is a little weird, but what it does for us is it means that we can just increment the dir directly all the time. Okay, so let's see where all we're using this. So this is good. This is okay. Sure. All right. And yeah, that one is up, right? Okay, so then we'll do this. Okay, so we only have to use that in get next, I guess. Maybe? Are we gonna have to use it in will exit? No, we are already using it in get next. Okay, so that's fine. Okay, so then this will be plus dir mod 4. I think I'm just gonna put the 4 actually in this case. No, let's just put dir's length, it's fine. Okay, so we can turn. All right, so then when we go to next state, we're gonna see if we can get next, then if we can walk, then we will walk. All right, so we'll put const walk. So dir is unchanged. Pause becomes get next. And guard map, of course, is unchanged. Okay, a little crazy. I should be using spread more for these objects, probably. Let me save what I've got so far. Okay, it did an unexpected bang. And where's the bang? Oh. Okay, so let's keep going. So can walk equals this. We'll exit, sure. And then we have turn. Okay, so then when we go next state, so we'll say if can walk then we return walk, right? Okay, so this doesn't need to be like that. This can just be game state. Okay, and then here we will return next state turn game state. So that's pretty much it. Okay, so wherever we have the guard map, okay, yeah, this looks fine to me. Legit, I think that's basically it. Now the problem is we could end up in an infinite loop pretty easily, actually, and that would not be good. Oh wait, I didn't close this. So it seems like it would potentially be easy to envision an infinite loop, right? So if this guy, well, I mean, even if the whole thing is just surrounded by hashes, then it will never end, right? So does it have a instruction for what happens if that happens? I think we have to assume that that's not going to happen. Maybe? All right. Let's try solve. So here's I. So let's try solve I. It came out with 6. That's way wrong. Oh my gosh. So apparently we ended up with will exit far too soon. It might have gone 1, 2, 3, 4, 5, 6 and walked right off. I like that robot head guy on YouTube. He does obviously more complicated things than this for the most part. Okay, so the pause. Okay, so yeah, so we walked up as expected. 6, 5, 4, 3, 2, 1. Sure. The guard map looks fine. Um, but yeah, so then it walked right off. So we'll exit. So Y presumably kept getting lower. All right. I did quite a few things that are a bit half-baked here, so which one is causing me my grief? Okay, so it came out as a dot each time, so not correct, because eventually it was supposed to be a hash, right? So let's see. So when we were at position 4, 1, so 4, wait a minute, wait a minute. Okay, so 4 is supposed to be on the X, so 0, 1, 2, 3, 4, okay. And 1 is supposed to be here. And then the next, at this point, was supposed to be the hash, right? But it wasn't, and we walked right off. Okay. Because this next was supposed to be 4, 0, right? Yeah, it says 40. So the guard map at 40, we thought should have been that. Nope, I have it reversed right here. Okay, it says 44, which is not right. It said it was supposed to be 41. Okay. So this time we were at 45, okay, 44, 43, 42, 41. Okay, so we see the hash as expected. Okay, so then we go 5-1. So that means that we're now at 0, 1, 2, 3, 4, 5, and here. So we've made a turn. That's as expected. Okay, and so then we keep going that way. 6, 7, 8. Okay, so 9 we find, oh help, there's something here, right? So we turn. Okay. Yep. So now we should go down until we meet this guy at 9, 7, I guess. Oh, it's 8, 7. Because that, okay, that's the next. Okay, so 8, 7. Okay, so now we go 7, 6. So we looked at this and then we went this way instead. Everything seems good so far. All right. So how come I counted 44 instead of 41? It's because we're supposed to mark positions. If he revisited a position he stepped on before, we're not supposed to double count it. That's the reason why. Okay, so for some reason I didn't grasp that at all. For some reason I thought we were counting the steps. Okay, so we're not counting the steps. Okay, so the final thing, so they marked them with X's, with big X's. Let's do the same. So we will return game state guard map dot map join match okay, so that means we will have to paint floor. So const paint floor equals pause guard map okay, so we'll paint the floor before walking. Okay. I got 40, so I'm 1 short. Let's console log the final game state. Okay, so in the final game state, we can see what we painted. And let's see if we can see which one we should have painted that we didn't. It looks like that would have been this last one right here, right? All right, all right, all right. So that means, so we stop looping when we will exit, but I do believe that this means that we want to paint the floor one last time before we end. Or, honestly, if paint floor was after going next state, then maybe, actually, yeah, that makes more sense to me. So we'll paint the floor once before starting the loop, and then we'll move, and then we'll paint the floor where we ended up. So I got the 41. Now, this one is pretty straightforward, although it took me quite a long time. How long did that take me? AI, how long did it take me to finish painting the floor on the guard trail? Let's see if it can answer. Spam alert, siren, talk. What's on your mind? Yeah, it's not very smart. Okay, so let's go ahead and run it, I guess. Here we go. So here is our, our fun grid. Let's say I equals, and we'll just paste this amazing grid right in there. Love it. 17 kilobytes. Okay, I mean, not too bad, not too bad. So then we'll just solve this fancy-pantsy thing, and I got 4890. Do I think it's accurate? I mean, I don't see why not. So let's see what it says. Okay, that's one. All right, so part two. Before I look at it, can I anticipate what I think part two is going to be? I think I had an idea of what I thought part two might be. I think it's got to be something about trying to find places to hide from the guard, right? Which could be, I don't know beyond that, but my guess is that that's the theme, is we're trying to find a place to hide. Maybe, but let's see. Okay, so here we're drawing crazy things. Okay. While the historians begin working around the guard's patrol route, you borrow their fancy device and step outside the lab. What is their fancy device? I didn't read the flavor before, the flavor text. Their fancy device. Oh, it's something from... Oh, from day 4? Huh, okay. The year 1518. Okay. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Huh, okay. Returning after what seems like only a few seconds to the historians, they explain that the guard's patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. Okay. Yeah, I did allude to the idea that there could be a loop, right? So, how are we going to do this? To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard's starting position. The guard is there right now and would notice. In the above example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 situations use O to mark the new obstruction, okay, and then a pipe to show the position where the guard moves up and down, and a dash to show a position where the guard moves left and right, and a plus to show a position where the guard moves both up and down and left and right. Okay, let's take a look. So if he starts here and he starts moving, okay, fun, fun, fair enough, okay. But now it's like, oh, it is a loop. All right. Okay, so then here we have another loop where it's like, okay, we're gonna move along. Everything seems normal. But then, oh look, we got blocked by the O right here. Okay. Chimney squeeze prototype fabric. Okay, so yep. We're gonna move right along. Everything seems dandy. Nothing's going wrong. Oh no! We hit this, okay. And now we're in a loop here. Right? No, this is bad. Okay. Put an alchemical retroencabulator near the bottom left corner. Alright, so here we go. Around. And then, here it is. And now we're just gonna go through these same four. Okay. A bit to the right instead. So now we end up, see, this is a more interesting loop, right? Because it's like, you know, more of a figure 8 type scenario, I guess. It's not a figure 8. I don't know what you call it, but it's like, it's not just a simple square. Put a tank of sovereign glue right next to the tank of universal solvent. Okay, so the final one, we're gonna see everything seems fine and normal. And then we finally come to here. All right, so now we're in this loop here. Okay. So it doesn't really matter what you choose to use as an obstacle, so long as you and the historians can put it into position without the guard noticing. The important thing is having enough options that you can find one that minimizes time paradoxes, and in this example, there are 6 different options you could choose. Oh, okay. How many different positions could you choose for this obstruction? All right, so based upon kind of like what we've done, where's my code area? Oh, let me close this. I don't need this. And so this is the Ramina. Yeah, we can close this. What's this one? This is the VPN. Yeah, we can close this. Okay. Is this where we were? Okay, so here's what we had for solve. So here's what we're thinking. Or here's what I'm thinking, I guess. So any of those spots that we painted with an X is potentially a spot where we might consider placing an obstacle, right? And so my first thought is we can just very exhaustively place those guys everywhere that gets painted with an X, one by one, and then check for a loop at each one. So one of the steps that we'll need then will be to check for a loop. Okay, so let me get this, and let's prettify this. Did it change much? Not really. Okay, well, this is what it looks like now. Okay, so we need a step for finding the loop, which is something that I felt like we kind of needed, but we got away without having it. And then just changing any of these X's to an O. So, I mean, yeah, pretty much. So I would probably say change each X potentially to a hash. So if we are doing this, so what is I set to, if anything? Nothing? let's set it to what it was before, just the small example code, small example input from here. Okay, so now if we go, let's grab all of these. That's not the final one I used, is it? That's got a bunch of extra console logs in there, right? Or no? So which was the final one that I used? This one, right? Oh no, the console log is still in there. Oh yeah, that's right. It did console log all that. Okay, well, it's fine. I'd forgotten that it console logged all that. Okay, so we'll say I. Okay, so we have I set to this. Okay, so let's run these one more time, just this stuff. Illegal return statement. I think I screwed that up. Okay, let's try again. Okay, so game state. Okay, so now let's do this part here. Here. So that matches all the X's, but I think we need to match all, probably. Oh, shoot. What are we looking at here? So if we match all, it says it's an iterator, so can we spread that? Okay, so they all have different indexes, right? Okay, so that says where each one is. Okay. So every one of these X's can potentially be replaced with a hash, all 41 of them, right? And then we'll just check to see if we loop. So what that means is we'll want to check to see whether we are in a game state that we have seen previously. So the game state right now looks like this. So we are not trying to worry about the guard map because this changes as we paint it, and so that's not part of it. We're only worried about the position and the dir, right? So we'll say game state ID equals D game state dir. Okay. And then I'll just say X game state pause 0 and Y game state pause. Okay. So this game state ID, if we ever find one that we've seen previously, then we can know that we are in a loop. So let's go back into our function. Okay, so here's our const solve. So now let's say const game state ID, all right, equals all right. I want to ESLint this as well as not just prettier. Maybe we'll get there. All right, so for now, I have this function, game state ID will take a game state and do all that. Okay, sure. Const scene states equals new set game state ID game state. Yeah? So let me change this. I think I can just say state. Okay, I like that a bit better. Let me enter to save, and now we'll say if scene states has let's say const ID equals game state ID game state. Yeah. But if this happens, I do want to console log first. Okay. All right, so now for our obstacle count, we'll say obstacle count equals I. And then we'll say init solution equals solve I. Okay. And then we'll say possible obstacles. And then we'll do that match thing we did a second ago, or like 20 minutes ago. I don't know how long ago, but like this. Where did it go? I hit a wrong key. I often do that. It's a sign of being dumb. Okay, copy. And we will totally... Okay, so that's not it. This. Okay, possible obstacles. Sure, great. So then return possible obstacles reduce. It's going to be a sum, so I'll put a 0 there. And we'll say const obstacled equals I. Obstacled dot or sub e equals hash. Return ac plus solve obstacled equals loop. Right? Let's parenthesize that part. So let's think about this. So basically I'm just running the whole thing like 4,000 times, right? Which is crazy and is going to take probably forever. I'm probably going to be sitting here for like 60 seconds. I would very much bet that there is an efficient way to do it that I just haven't thought of. How much time is on the clock? That being said, it seems to me that this might kind of do it. So let's try, what's in our eye? Okay, let's try obstacle count. So this one is obviously small, so it should be fairly quick. Probably close to instant, but when it's 4,000, it'll probably take forever. All right, so what did we get? I got a 0 in the end, so that's not right. So did we actually put the hashes in places as I thought we should have? We ran it like 40 times, right? So this is our solve definition. Um, so in the obstacle count, I feel like I'm not sure that this part worked. So like if I do have a string like a equals cat, cat sub 1 equals u, or excuse me, a sub 1. So now a, so, oh look, see a is cat still. Trying to assign a sub 1 didn't work. So it is actually a dot replace. So we don't want to search, we want to go by index. Okay, so I'm gonna do a const string replace equals SIC, and that's gonna be S dot substring so if we go a substring 0 1 and then 2 0 I plus C plus S substring, right? So now in the obstacle count, we will place that. So we don't do this. We're going to do string replace IE hash. Okay, so we can get rid of that. That's in cannot read properties of null reading 0. At get start. Looks like it did run through a few times, quite a few times, I guess. I don't think any of them came out as loop yet. All right, so cannot read properties of null reading 0 at get start. At solve. Okay, I do not want to be doing that. So in get start, oh, we did not, oh, we overwrote it, of course. Of course, that's messed up. I think it specifically said, yeah, it did, right? It specifically said we can't put the obstacle right on the guard, right? That was like the first thing it said, I think. Can't be placed at the guard starting position. Okay. And I didn't pay attention to that until now. So, if if I sub E match so we'll skip over it that way. Whoops. Okay, so I got the 6, and it didn't look like it took that long. It looked like it went through everything. Okay, let's move on. Okay, so here it is. Let's see how long it really ends up taking. I'm thinking like, it could be like, I mean, honestly, if it's more than like 2 minutes, then I'm probably gonna have to give up because there's no telling how long it's gonna take. I don't think it's gonna be that bad. That's why I'm doing it this way, but it could be. Oh, it came out. Oh, interesting. Why did it stop? I don't know what happened. Let me look at it again. There should be over 4,000 of them. Maybe it stopped me for some reason. Oh, there's only 41. Okay. But wait, why is it saying 0 now? It shouldn't be 41 here. Okay, so it's because I'm referring back to game state. So that's our problem. It should be init solution. No, hold on. So solve, yeah. I am completely out in the woods. Okay. Solve doesn't actually return that, right? Solve just returns that length. So what the heck was I thinking? So now in here, that should be more like it, I think. Okay, let's watch it run for like 10 minutes or something. I don't know. Probably too much console logging, but whatever. That's my answer. Okay, so I sort of almost exaggerated how worried I was about how much time it was going to take, but I was worried. Let's see if it's accepted. Let's go back to here to home. Okay, so it's still 2 hours left. So I think I will probably finish 7. Not quite 2 hours. 1 hour, 56 minutes before number 8 unlocks. Okay, so I'm gonna look at bridge repair. I don't think I'm gonna get to exorcism today. Uh, I'm gonna try and get plenty of sleep. Tomorrow I'm gonna be on quite a bit and try and knock out quite a bit of exorcism. To be honest, what I'd like to do, I mean, I've already used so much time just on this stuff. It's crazy, actually. But what I'd like to do is finish knocking this out and then knock out some exorcism tonight. But I feel that I'm lowering my expectations, and my mental energy is really... All right. Let's see. Oh, you know what? I spent so much time on that madness. I kind of feel like I want to save it. Okay, so I'm gonna go back to here. Okay, let's paste that. And this. And finally, this. So yeah, man, there's so much here. And I mean, I think some aspects of it do kind of interest me. I feel like I might enjoy going back to refactor this. And like think of like somewhat less inefficient solution maybe off the top of my head. I don't know. It's one of those days that I feel like I'm never going to be smart again. That's probably pretty much every day. All right. Okay. Let's knock out whatever this next one is. All right. Which of these can I close? Should I close this for now? Am I not using? I think I'm still using it. I'm using that, of course. I'm going to be using this. Okay, well, I can at least close a couple of tabs. So that's better than nothing. These stay open, that stays open. Okay. So this one I'll be working with. And this one. And this one. These three. These three should be at the top. Nope, not that one. This one, this one, and this one. Okay. All right. So the bridge breaks pretty frequently, I guess. So we have lines representing equations. Okay. So there's a test value 1 to 90, and then there are numbers 10 and 19. Okay. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. So for example, if we multiply 19 by 10, and it's like, okay, sure, we can get 190. Oh, this feels familiar. So we can see elephants with add and multiply. And it is always left to right. Okay, so great. So if we go 81 times 40, what does that bring us to? 810 times 4? I mean, I don't know. Let's see, 3240 and then add 27. Yeah, so that would be it. So we would times first and then add. Okay, sure. Interesting. Interesting. So the first two are okay. So here we can see, all right, so we multiply them together, and then we get 17 times 5, and like, what even is that? 85, so that's not it, right? And if we add them, we get 22, and that's not it. And those are our only possible options. So it's no good, baby. It's just no good. Very sad. So, sure. So we have to find which of them are true and then just add them together. So this one does seem like probably much shorter, I think, to solve. I believe. So we will see. We will see. So it's kind of a tree thing, right? So we're gonna be past this string. Okay, so we'll come in here. Okay, so we're starting fresh. So first things first. So we'll say I equals, and we'll put that in there. Okay. So then we'll say I split like this. Okay. Map. Okay, so array 2 everywhere. Good. And then this part will become so that's our test value, it said. And then the remaining numbers. All right. Should we do that? 15 and 6, 6, 8, 6, 15, 16, 10, 13, 17, 8, 14, 9, 7, 18, 13, 11, 6, 16, 20. All right. So then our helper is going to be like helper equals, so we'll pass in A, and then we'll say if A length is 0, let's say, yeah, if A length is 0, return 0. Just happened here. Oh, I think it's okay. If A length equals 1, return 1, right? And then we will return no, that's not right. It's A sub 0, excuse me. All right, and then if A length equals 2, return A sub 0 plus A sub 1, A sub 0 times A sub 1. Okay, and then finally, we'll do what, a slice of it basically. Let's just pop. So then we'll say const x equals a pop. And then return let's say const result equals this, and then helper A for each n result push x plus n results push x times return results. Okay, so on this split, let's say processed input equals, okay, all right, so then there's going to be an n, I guess, in each one. Sure. All right, so what kind of results did we get here? So you could get 29 or 190, makes sense. 22 and 85, yeah, so this is kind of what we were looking at before. So then to get the final sum, we're going to say sum result equals e-test. So it didn't come out right for, okay, so we see a problem potentially. I see a 3267. Where is, let's see, 3267. Okay, and I do see that here. I've got a true here, but the rest came out false, because why? Three, 2, 6, 7. Yeah, I don't know. It looked like that should have worked. But it didn't. 292 is here. Love this one. Love this track. Alright, so what got console logged? So these matched, so we were good, right? Interesting. Oh, what? Okay, I modified them all by popping, so that's actually obviously not acceptable, but we can avoid that. So let's say I is like this. So now we'll set the processed input again. So yeah, I honestly, in my mind, I don't think I said anything out loud, but in my mind I was thinking I shouldn't mutate that. And then I was thinking maybe it'll be fine. It wasn't. Sometimes it could be, but in this case it was not. Alright, so we'll say processed input is this. Then we'll redefine our helper so that it doesn't mutate that. Right? Okay. And then... And it was confusing too. It was like a classic case of mutating something without remembering that I'd done so. Okay, so that's right. So then what if we put just like number here? So then I get the 3. And yeah, I think that's right. So let's define a solve. So we'll say const solve equals, I will come in again. We'll say const And we'll set the processed input as we did here. See, this one is much shorter than that last one, right? I don't know if that's necessarily the case. Maybe that other one was just as short for a lot of people. We'll see what happens in part 2, though, of course. So we'll set the helper there. Then we will return this. Okay, so let's just throw it into prettier. Okay, so that's what I have. Now, let's see, we're gonna go solve. Okay, so let's solve and put this input in there again. Is it this one? Yeah. Okay, so it says 3. Do I anticipate any particular problems? I think this helper is sound. That's the nice thing about recursion, is they're just easier to reason about, I think. Or they can be. And in this case, I think it is. Yeah, let's just see. And then I do feel that this one will produce the correct result, and then we'll see what happens in part 2. We'll see what happens in part 2. I'm expecting this result will be right. Let's see what it says. Your answer is too low. Darn. Here I specifically said I wasn't expecting any problems. That's crazy. All right. So I don't anticipate any problems with the processed input. That part should be okay. I think I must have left something out of the helper. Okay, so for one thing, let's get rid of this base case because I don't expect that to come up. I'm just going to simplify a little bit here for a sec. And let's get rid of this base case. I think it's unnecessary. This should be the only base case that we expect to require, right? Okay, so return to day 7. I'm going to struggle to finish this one clearly. Okay, so let's put that in. Okay, come on. I think that that discovered my problem. I think that very likely was the issue. No, that can't be, because it would have said this same thing, right? Shoot. Right? I think so. Okay. Let's see what it says when I throw the big one in again. Is it still 290? Or 210, excuse me. 210 is what it was before, right? Wait a minute, wait a minute. Are some of these larger than that? Like, that's really big, right? Okay, so it's still not past that point. Okay, so no warning for the number is big. Some of them are pretty big though. Some of them are pretty big. Um, it said it was about elephants, right? Okay. So then it's like this. So then these should all turn to number. Wait a minute. What if we have ones or zeros? That shouldn't make a... I'm seeing ones different places, but like that shouldn't make a difference, right? Like it should be pretty straightforward, I believe. I think that this might be like a genuine edge case situation where some edge case may genuinely have like thwarted me, I guess. Maybe. That's a little clearer to me, I think. Okay, so then helper, we call helper on the copy for each. Wait a minute, wait a minute. Did I do some out of order? Because it said they're meant to be strictly left to right. And I didn't pay that much attention to the order. So if we work through this, let's say we're doing this one. 281, 482, 1719. We pass those four into here. The length is more than one. We make a slice. Okay, so now we pop 19, sure. Now we push x plus whatever came out of here, and x times whatever came out of here. But are those going to go in the correct order? So the order of these doesn't matter. I think they will go in the right order, but um let's try just taking a look. Huh. Yeah, you know, I'm not sure. I thought this would have been okay. Let's see if there might be something else. Always evaluated left to right. Okay. Numbers cannot be rearranged. Sure. I didn't add them up. I completely forgot. I completely forgot that we were adding them up. Oh my gosh. Okay, so in the sample it was supposed to be 3749. Oh no. Okay. So filter. That is crazy. How much time did I just spend looking at that thinking, oh, what's wrong? Okay, so that's not it. 3749. Oh my gosh, that is so funny. That is so funny. It's sad too, actually. It's not that sad. I'm having a good time, baby. All right, let's solve this again. Is that bigger than... How much is... These are such big ones. So this divided by... So we're still 400 times higher, but man, we're getting a couple orders of magnitude. We're still fine. We're still totally fine. It just looks big. It is big, but it's not that big. All right, so yeah, sure. Let's put this number in. It's a doozy, but yeah, there we go. Okay, part 2. What? All right. Sure. Let me look at what I did. Do I want to refactor or anything? So this is what it was. Um, yeah, I do want to put one more warning. So I'm gonna say const result equals, and then say, let's make this a warn actually. I'm just gonna put that down here. Okay. All right. So what could it possibly be for the second part? Let's see. The total calibration result is nowhere close to being within safety tolerances. Some well-hidden elephants are holding a third type of operator, the concatenation. Oh, okay, cool. Very fun, very fun. Huh. Well, so this hardly seems any different. So do you think it's an easy one because it's a Saturday? Do you think that's deliberate? I don't know. I would think Saturday might be, if anything, one of the harder ones and make Friday the easier one. I would say make Friday the easier one. Yeah, I don't think they've done anything deliberate like that. Yeah, this seems like it's probably simple. Maybe I'm crazy. I mean, that's all that's needed, I think, right? So it says it should now come out to 11,387. Let's try it. Nope. Nope, nope, nope. That is not it. Okay, so 156. 21, 90, 615. Okay, so apparently we did in fact skip over it. So why is that? Let's see. Return, slice, pop. Okay, it's because I have them out of order. Yeah, okay. Let's just fix that. Easy to see now that I take a look at it, actually. Okay, so there's my number, 11,387. Okay, let's turn off that console log. Okay, so if the numbers get too big, it will warn me. Let's see what happens. What? What did happen? Oh, a number came out. Okay. So I believe what happened here is that in this particular case, I actually just sort of immediately knew the approach to the problem that would kind of make sense, which was to do it using this recursive method, right? Because we're just trying to get all these combinations. And like, I think a lot of people who do this probably hit upon like a pretty good method. See, like, I mean, here's the thing. This method, I don't think it's efficient, but I think it was just very easy to code to the point that I was like, yeah, that's the obvious way to go, you know? It would be interesting to see what people do who go for an efficient solution on this one, but yeah, I was just like, that's so obviously the easy way to code it. That's just how I want to go. Anyway, let me copy that and put it back into my prettier. And then we're going to look at exorcism. That's what we've got, baby. Yeah, not too bad, not too bad. Okay, exorcism. I wonder, it might be, they might have released the last week by now. Let's take a look. Nope, not yet, not yet, but it's coming. We're getting close for sure. So for today, what I want to do is do one that I haven't completed any yet, not prologue. Kindergarten Garden. I can't imagine what this might be. It's probably not too bad. I've heard awk has kind of a weird reputation, but I don't think the other awk program that I did was too bad. Let's hop right in. Let's do it. So this is Kindergarten Garden. Let's do it first in C. We'll see how it goes. C can be tricky, but it certainly isn't always. A lot of times it's just very nice. Let's see. We need to be in exorcism. C. Nope. C. Kindergarten. All right. What could this be? All right. Can we see that okay? Yeah, that looks nice. Okay, so it's called Kindergarten Garden. What's this song? This is another one that definitely belongs on the playlist. Abusey Junction. We out here? Why is it called Abusey Junction, I wonder? Welcome to Kindergarten Garden. All right, so the kindergarten class is learning about growing plants. The teacher thought it would be a good idea to give the class seeds to plant and grow in the dirt. To this end, the children have put little cups along the windowsills and planted one type of plant in each cup. The children got to pick their favorites from 4 available types of seeds: grass, clover, radishes, and violets. Your task is to, given a diagram, determine which plants each child in the kindergarten class is responsible for. There are 12 children in the class: Alice, Bob, Charlie, David, Eve, Fred, Ginny, Harriet, Eliana, Joseph, Kincaid, and Larry. 4 different types of seeds are planted: grass, clover, radish, violet. Each child gets 4 cups, 2 on each row. All right, so window, window, window. Each dot represents a cup. Okay. So what are we going to do? Their teacher assigns cups to the children alphabetically by their names, which means that Alice comes first and Larry comes last. Okay. Here's an example diagram representing Alice's plants. Okay, so Alice gets the first 4, and she puts her violet, her radish, and her grass. Is it intended that she has radish twice? Okay. Your program will be given the plants from left to right, starting with the row nearest the windows. Okay. From this, it should be able to determine which plants belong to each student. For example, if it's told that the garden looks like so, And if asked Alice's plants, it should provide violets, radishes, violets, radishes. Okay. Well, it sounds simple enough. Let's just discuss briefly like what the approach is going to be. So some input is going to come in, and I guess we'll have to save it. Is this going to be sort of a kind of an oop type thing? Like, let's take a look at the test. So there's nothing in the setup or the teardown. So actual. So here's expected. And then the test function will take in a diagram. Okay. Okay, so we don't have to even save this. We just, I guess it'll be passed in each time, so that's good. Huh. This one's okay. It seems okay. Now let's see how we run our test. I think we have to do something. Looks like this might be okay. Let's take a quick look at the help. I know the setup for C is a little more intricate sometimes than some of the others. So if we do make test, then it will say what? I guess it's ready to go. Probably. So here's our C file. Not used directly. Is there anything in our header? Do we have stubs there? Okay, we do. We have a typedef struct. Plants. Okay. Looks like we need to put our function in here as well, right? So we'll go test kindergarten garden C. Okay, so over here is where we need to create our function, right? Whoops. So it's going to be called plants T plants takes a diagram which is char star diagram, and it takes a char star student. Yeah. Now, so now that I have that, so in here, we should have some kind of function definition, right? So plants T, plants, char star diagram, char star student. So then this is a struct. So let's return so it's just a struct with an array of 4 plants, right? Okay, so I don't think it's quite right. Let's see what make test says. Expected expression here. So let me see if I can remember. So I don't really remember. So here, I want to say we have to say struct? No. I did it. Let me look at one of my others. I am way off. Did this have a struct in it? Maybe? Okay, so this is how we did it. So we said circular buffer t init buffer equals, and then we put all the fields in there, right? So I'll say plants t result equals oh, look at that hint. That looks kind of neat. I could get used to something like that. I think I need to set up a styling for my editor. Okay, now what does test say? In function plants, unused parameter diagram. Unused parameter student. Okay. All warnings being treated as errors. Okay, passing argument 1 of plants discards const qualifier. Expected char star, but it is const char star. Okay, let me fix those. Okay, cool. So unused parameter diagram. Okay, so we're gonna have to use it. All right, now does the actual like solution seem like it should be simple? Honestly, I am not too sure. So the weird thing is, like, I feel like I do need just a table of the names that were given in the README. Because if we look at the test, those names get passed in, right? Alice, Bob, Charlie, Alice, Bob, Charlie, David, Eve, Fred, Ginny, Harriet, Ileana, Joseph, Kincaid, and Larry, right? Okay, so they all start with like a J or a K or whatever. So one helper function is going to turn the name into a number, I guess. And then a second helper function is going to turn the plant letter into a plant. And then we're going to tie the whole thing together. All right. So we're going to say plant T, plant, const char init, switch init, case C, return clover, right? Case V, return violet. Case G, return grass. What was the fourth? Radishes, and that was just an R? Okay, cool. Case R, return radishes. Default, return clover. Okay, so const char star invalid. So can we do, no, that's address of, excuse me. Violets. Okay. Function definition is not allowed here. Okay, okay. Man, that LSP is pretty good. I am going to schedule time, and it's not going to be until the new year, but when I make my calendar for 2025, I'm already planning that I'm going to plan for 3 or 4 different dates during the year that I'll do a stream and just take 4 hours to spruce up my dev environment, because what I've noticed is that I don't do it. I don't spruce up my dev environment. It's dumb. I'm going to put 3 or 4 dates on the calendar specifically scheduled in advance throughout the year to spruce up the dev environment, because this editor needs styling. I need to learn to use the editor better. There's a bunch that I need to do. And it doesn't need to be a lot, right? Like, I think just like 3 or 4 times a year would go a long way. Okay, so that's one of the helpers. So then we're going to have an int, and it's going to be student number. And this will take a const char star student. Okay. And then this will be return star student. And then let me just take a quick look. So if the name is Alice and we go char code at 0, it's 65. And what do we want it to be? 0? So subtract 65. What's that say? Okay, love it. So now, let's see. So now we're going to have to take, like, the plants from the diagram, right? So we're going to say const, or no. Let's say int n equals student number, student, okay? All right, so then we're going to need to use the n, which is going to be int start equals n times 2, int end equals start plus 2, okay? And then let me take a quick look at the diagram again. Okay, so when it's passed in, it's 2 letters, a new line, and then 2 more letters. Or if it's longer, then it's like a bunch of letters, and then a new line, and then a bunch more letters, right? Okay, so let's see. Okay, let me close this again. So are we gonna have to look for that new line? Wait a minute. So when we do the test, it's diagram. If we've got to look through that new line, I guess I'm just going to go through in a loop, which is fine. All right. So we'll go for int I equals 0, I less than, I don't even know what, right? Because we don't exactly have the length, I don't think. So less than end, yeah, that's where we've got to go to, right? Okay, so that's not it. So we have to first of all go result plants sub 0 equals plant diagram sub start. And then, yeah. Passing const char to const char pointer. Okay, so let's just say address of. I love that hint. Man, this is gonna be a good experience. This is gonna be a good coming year. Result plants sub 1 equals so okay, so we're gonna add one here. Okay, cool. And so for int I equals end, well, shoot. Let's say while diagram sub end not equal end plus plus. Should we do that? Yeah, I think that seems good. Is it too weird to put the plus plus in here? Okay, so now that we have that end point, then we need to add start to that, right? So we'll say result plants sub 2 equals plant diagram start plus end plus 1, right? And then here, 3, 2. All right. No previous declaration for plant. So does that have to be in the header? I guess it does, right? Yeah, that's no big deal. I just, I don't know this stuff because I don't really practice, but this coming year, I'm going to be practicing a lot, is the plan. We'll see how it goes. Okay, so let's copy this. And this. Okay. Element 3, expected 1 was 0. Okay, okay. So whatever it was, we got it wrong. Ha! So they're all ignored. Let's unignore and see if we... I mean, if that one failed, then they presumably all fail, right? Element 3, expected 1 was 0. Let's turn them on. Okay, so test ignore. Delete this line to run test. Okay. Pass on Bob, second student's garden. So what is that one? Wait, was it the full garden? Yeah, test full garden for Bob, second student's garden. So this one apparently passed. Clover, excuse me, clover, grass, clover, clover. Yeah, it seems like I probably made some simple, silly error somewhere. Expected 1 was 0. Expected 0 was 1. Expected 3 was 2. Okay. Okay, so we're supposed to switch on the initial C, V, G, R. Okay. All right, did we see some output come out of there? In this case, no, we didn't. Is there a suggestion for how to debug here? Okay, 3 rules. Oh, the output comes over here. Okay, fair enough, fair enough. Well, looks like a mess, so that's not encouraging. Yeah, help me out. This is beginner stuff. Okay, so printf. So int n, scanf. Okay, so printf. Yeah. Okay, I mean, that's kind of what I thought. Okay, printf. Oh, okay, there they are. Okay, so 0 is as expected there. However, yeah, okay, yeah, these start numbers are as expected. So that's not the problem, I don't think. Okay. C printf char. %C. Thanks, AI overview. So GVV. Okay, so these inits seem okay except this one. So that's not good. Okay. So in this first one, we were supposed to see RCGG, and that's not what we see, right? We see RCG missing the final G. I guess I'm off by 1. Ah, you know what? That does make sense. And I like it better this way. I wasn't thinking about the fact. Okay. Let's see if this is any better. 17 passes. Okay. Something feels delicious about coding in C. Like, all of the tricky things feel like things that should be tricky. I don't know. Maybe it's really just aesthetic enjoyment, I think. Let's do submit. Okay, opened up over there, because I keep being weird about my alt tab. That's another thing that should probably be on my list for upgrading my dev environment. Okay, so that's fine. So now let's take a look and see if I want to refactor. Let's start with the H file, which should be fine. Yeah, I'm okay with that. And now the C file. Okay, it's pretty small, which I think is appropriate for this. Okay, so this default return clover, that's insane. Why would we do that? So what should we do instead for the default? And then initializing the plants like this seems weird, unnecessary. Um, so let's get rid of that. I'm gonna say maybe 0. And here I'm gonna say 0. And then I'm mostly okay with this solution, I think. So we only use the student number the one time. I think I'm actually gonna get rid of it. I'm gonna put this down here before it's actually wanted. I think that's pretty much all I want to do. And then we'll get rid of this, which was unused. Okay. Opened up over there again. Because I keep messing up my alt tab. I've been doing that all the time. Alright, let's see if I've got music. Okay. Sure. Okay, so I'm gonna mark that one as complete. It's not getting super late. So so that one, I guess I didn't know what to expect. So this one is marked as a medium. Interesting. Not sure why that would be. Probably just, I don't know. Yeah, I wonder how they come up with these. I imagine it's mostly because obviously C is a little bit more demanding than programming languages like Ruby or whatever, but this was not a demanding problem at all. All right, so let's go back to 48 in 24. And let's do awk. Okay, could be interesting. So I did one in awk already. It seemed nice. I don't think it was too bad, but I don't feel like I really get awk very much, but we're gonna hopefully get it a little bit more now, because we're gonna practice with it just a bit. Okay, so let's take a look at the help to review. So for awk, we're gonna use the bats program. So let's try running that. We're gonna bats the test. Okay, cool. So yeah, that looks good. All right, what else is in here? Okay, quite a bit of information. So bats, there will be a here string used apparently. Okay, sure. And approximately the same as just piping something in there, so that seems good. Okay. Let me quickly review my other one. So it was this. Okay, so it wasn't a very big thing, so it was pretty straightforward. This is a straightforward problem, right? Like we're just doing some arithmetic. So if sum mod 10 equals 0, print true, else print false was part of it. Okay. So in this one, let's see that test again. So they said from function assert success. Let's see, status. Oh, okay. Implement this solution. Okay, let's go into the awk file. So it says print implement this solution, exit 1. Okay, so we won't do that. So it says the name is initialized on the command line. Okay. So what if we print name? Is that a possibility? Okay, so expected radishes, clover, grass, actual Alice. Okay, then let me look at this solution again. So here, so I just called gensub, and it like, whatever had been passed in was kind of just available there, I guess. So like, if I were to go, instead of print name, if I were to just go print, oh, should probably be print, plain print in begin or end rule should probably be print nothing. Oh my goodness. So in the test, we see that name equals Alice is passed in as V here, dash V. And then end garden becomes something which goes, let's see, end garden. Different garden with single student. So we're skipping here. And then we're going to say run gawk, name equals Alice. Okay, so now here we're actually putting some strings. Okay, so this is the string. Oh, goodness gracious. Wow. Huh. Okay, cool. Okay. So what if I do just put print, right? And then we go bats. Okay, so it did print nothing. Okay, is this what did I look at before? Which one of these actually helped me? This one was a while ago. October 26th. Oh, goodness, that is a while ago now. Kinda. Alright, so did the GNU awk user guide help me? I think it did. It looks like I was there quite a bit. Okay. Did this help me? Begin, end. So here I did not use begin. So I don't think I want to use begin here either. So what'll that do? Ah, yep. RC. Oh, yep. Okay, this is gonna be good. This is gonna be good. So we have something there, and we have a name. Okay, so now we want like a substring. Let's see here. Awk char to int. Um, oh no, what is all this? Ah, no. Ord? Ah, just like Python, baby. I bet this one came first, right? Awk is... I think I understand that awk is, I guess, pretty old. So ord and char, yeah, these are the same as the way they're named in Python. Cool. Okay, so ord is not defined. So no wonder this guy only... He got 3 thumbs up, actually. And he didn't say it would work, he said you can try. Okay. Um, okay. So... I guess fair enough. This is the ord init. Force to be numeric? No way. What's it gonna say? Let's see, so this came out as 0, so that's not very good. It says 0. Nope, it still says 0. Awk charcode. Here it says ord. All right. All right, we'll do it. We'll do it. It's fine. Helpful suggestion from so we'll say 4. Should it really be formatted that way though? It's just because he was one-lining it in on the command line, right? No way. I think there's something wrong still. Nope, it's fine. Amazing, amazing. It is fine. Okay. Okay, so now we used like variables and things, right? Oh, no, 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 no. Yeah, we just assigned it like that. Easy peasy then, right? So we'll say, radishes, clover, grass, grass. Okay, so nothing came out, but maybe getting closer. So let's see. So print $1. Okay, so I see that part at least. Oh, I never subtracted the 65. Okay, so I see the R and the G. So now I'll say plant sub R equals radishes. Should I do that? Plant sub G equals grasses. Plant sub V equals violets. Plant sub C equals clovers, right? Okay, so I see radishes, radishes, grasses, grasses. Okay, well, one of those should have been clover. I have got way too much output coming out. Hold on, why am I showing RC so many times? That's definitely not right. So what's happening there? I go print plant substring. Oh, these are misplaced. Hold on. Okay, that's a little bit more like it. Okay, so now I still have radishes where it was meant to be clover, right? RGVC, okay. RRGG. Okay, yeah. So it's supposed to be a C somewhere in there. So what's the deal? Wait a minute, wait a minute. Where was substring? String start length. First character is character number 1. Oh, really? Uh-oh. Um, yep, those are the ones. Okay, so now I guess we have to add these to a string and then print at the end, right? So end will be print result. Okay, and so then begin will be result equals this. And then here, instead of printing anything, we'll say result plus equals plant init 1, right? Okay, so it came out saying 0 when I went to try to print result. Okay. Append. No. Awk string append. Concatenate. Okay. So we'll say okay, got a little extra space in there. Interesting. Close. There's an extra space at the beginning. What's that about? Awk string trim? Yeah, hit me with it. a G sub at the start. So gen sub takes regex, replacement, how, target. And I used that before. Okay, we're gonna give it a shot. So we'll try a gen sub. We will put a regex, which is any white space at the start. And then, oh, is G the flag? No, what if it, how? Okay, so it's gonna be either this or, warning, gen sub is a Gauck extension, or at the end, so that is that. Then we're gonna put the replacement, and then we're gonna put the G, and then we're gonna put the result. Okay, so then we're gonna say, yeah, let's test it again. Okay, 16 skipped. Oh, so much. 14 failures. Okay, okay. So a lot of these are wrong. It's a little trickier than in C, in my opinion, perhaps, but we'll see. Okay, so this time... Okay, let's do garden with 2 students, first of all. Okay, so garden with 2 students. This is the one we're trying. So it's not working. So if we say, what was that again? Bats run the skipped. Oh my gosh, where did it go? Bats run skipped. equals true. Okay, so then if we say false, or maybe 0, I don't remember how that works. Hold on. Oh yeah, you just do that. Okay. Okay, so it did all of them. 14 failures. So I want to turn on the ones that, so single student, different garden, and Alice should be turned on. Okay, garden with single. And the other one that passed was for Alice, first student's garden. Okay, so the one failure. So expected clover, grass, radishes, clover, actual violets, clover, violets, radishes. So it seems like completely wrong, right? Completely wrong. That's okay, we'll take a look. Okay, so this seems sensible so far. This seems okay so far. Okay, so as we go through, let's print n, print init 1, print init 2, print result, print result. We'll take a look. Okay. So with 2 students. So expected was clover, grass, radishes, clover. So I'm looking at VVCG apparently, then 2VC. And I put violets, clover. Okay, so I'm very much off by 1 there. Oh, I never multiplied by 2. I actually completely slipped my mind. Okay, so now let's turn those on. Or let's do skip or bets. Okay, so they all ran. Let's take a quick look at how we want to refactor. Okay, helpful suggestion, yep. Okay, let me get rid of the prints, I guess. I don't know. Okay, this part makes sense to me. I think this part seems okay. Um, Actually, that's probably not necessary, is it? What if we do that? Does it still pass? Yeah. Okay, so that's good. Um, let's look at the for loop syntax. Awk for loop, for statement, for body. I think this seems okay. All right. So then I think begin is fine. These variables, I'll get rid of that. Or actually, no, that's fine. Let's leave it. Okay, so then this part. So gen sub is a Gawk extension. I'm gonna leave that alone. I'm okay with it, I think. Um, this makes pretty good sense to me, I think. I think I'm gonna say we are all good here. Okay, let's test once more. And submit. I think that I kind of dig this awk programming language. It seems kind of aesthetic. I think there's a lot to like about it. Okay. All right, so that was good. Let's look at the third one. Perl? I don't... Maybe I will feel better about Perl. I don't think I had a good experience, or I don't think I enjoyed my experience with Perl, really. So we're going to hit it again and see if we like it better this time. Perl was one of those that kind of rubbed me the wrong way. I think I'll like it better this time. We'll see. So interesting. So it was the same problem as in awk. So let's see what the Perl version looked like. Oh, it looks horrible. Perl, yeah, somehow Perl has kind of rubbed me the wrong way. That's a shame, actually. I put a bunch of commentary in there. Use exporter. Oh man, yeah, I don't know. Just right off the bat, it's just I don't know. I think it's fine. Let's do this one. I think I will like it better. So it's gonna be lib. Okay, so here is our file. Hey, it filled this part in already. That's neat, I guess. Diagram and student. How late is it getting? I need to get to bed, actually. So, I'm not gonna do this right now. I think I don't personally really like the Perl syntax very much, honestly. So, I would say I would like to find something to appreciate about Perl. So Perl historically had the good, like it was known for having good regex support, right? But now all the programming languages have that. Let's look at Wikipedia Perl. What is it that we should like about it? General purpose Unix scripting to make report processing easier. Okay, cool. Borrows features from C, SH, awk, sed. Makes sense. Highly expressive. Source code can be short and highly compressible. So maybe that's where I need, yeah, you know what? Honestly, maybe that's where I need to find some joy in Perl, is by trying to keep it terse. The Swiss Army chainsaw of scripting languages. The duct tape that holds the internet together. So, like, I don't know. Ooh, Perl 7. Perceived inelegance. Oh, dang. In 2020, someone announced Perl 7. Oh, wow. There's more than one way to do it. Large collection of language primitives. Huh. Yeah, I feel like I could appreciate this language. I mean, I should read the whole thing. So I am not gonna read the whole thing right now. I'm gonna log off. It's getting late.